right, okay, it looks like that's up. So let's go ahead and get started. So I am going to cover over the next, I don't know, however long until I get, feel like I'm done, just getting started with Go. So on YouTube, I'm kind of streaming a set of videos on just live coding as I go along using Go. And yes, there will be a number of Go references and Go puns here. So let's get started. Um, if you're thinking about using Go, you need to install Go. And I'm not going to go through that. You can look on the website. There have installers for and instructions for your platform of choice. I'm on a Mac, so let's go ahead and grab Visual Studio Code. And we're just going to download this. And the reason I'm using Visual Studio Code is it is freely available and it has fantastic support for Go. So if you're new to Go, I highly recommend grabbing Visual Studio Code, and I have not installed it on this machine. I've been using something called GoLand, which is a great IDE, but it is a commercially, commercial product which people do charge money for. So not everyone is ready to plunk down so yeah, let's do that. All right, so getting started with Go. Well, we want to install the Go package here, and if you look, there is one, and you can tell generally speaking in Visual Studio Code, you can tell you've got the right package if you look and see a high number of downloads. So this is 5.6 million. Not every package that you're going to download is that massively well used, but there are 5.6 million downloads of Go. I think I'm responsible for like 30 of them. So it doesn't mean that there are 5.6 million people using it. It just means that it's been downloaded 5.6 million times. All right, so let's go ahead and install the Go language. All right, great. With that done, let's go ahead and create a new project. So File, New File, or let's do Open Folder. And I'm going to go ahead and in my projects directory, oops, I didn't open my projects directory, File, Open, and Projects, and I'm going to go ahead and create a new project, and I'm going to call this Get Going 01. Okay, so let's open Get Going 01. Yeah, trust. All right, so there are no files in Get Going 01. So I'm going to go ahead and create a new file, and I'm going to call it getgoing.go. Okay, so automatically we've got a little red squiggle. That's because we're not telling it what package this is in, and that's something that the Go file needs at the top. We need at the top of every Go file. So I'm going to put this in package main. And what package main does is allows us to create a standalone binary executable program, and we're going to go ahead and define a main function. Now, for a lot of you, just take this as a given. Go ahead and just mechanically use package main. If you'll notice, there is an auto-completion option there. And if you notice, there's also all right. So let's do something with our program. So we're going to go ahead and just say hello. So this is the thing that we do with all programming languages, basically, just to make sure everything's installed correctly and everything works. That is good coffee. I highly recommend the coffee I'm drinking. So let's go ahead and do fumped. The fumped is the format package. It's where a lot of your functions are for printing stuff or formatting output. But we'll start with fumped print ln. And this is, we're going to give it an argument and it's going to print it out on that argument to the console. And we're going to say hello world. Okay, great. We still got a little red squiggle. Now, to make the little red squiggle go away, I'm going to go ahead and save the program. And the way the Visual Studio Code extension works is that you go ahead and save, and that runs a program called gofumped. Gofumped will in turn format the code appropriately and will also import any packages that you refer to. One thing that you may be different with your experience as you install the Go package and you start your Go program, you may get a dialog down here that says, "Hey, I want to install some tools like gofumped or GoCode or whatever." And when you see that, go ahead and click Install All. And what I might do in the next video is I might remove all those tools and have those get reinstalled by Visual Studio Code during the build, during the setup, again, so you can see what it looks like. But go ahead and install all. Okay. You see if they've got it in here. No. They do have a lot of setup videos and stuff here. So there are plenty of resources, and I'll go ahead and put links to all the resources in the description of the stream. But the key thing is the key thing is to get the Visual Studio Code and Go installed, and once that's done, the rest of it goes actually pretty smoothly. So getting back to our program, we've got our hello world. So let's go ahead and open up a terminal, and we're just going to use go run. And what this is saying is telling Go to just run in the main package in this directory. And what Go will do is on the fly, it'll compile everything and run it. Okay, we don't have a Go mod. Let's just do this instead. There we go. So the reason this one failed, as opposed to this, which is telling Go to just run our file, if I do an ls, you'll see that I've got my get going file here. The reason this failed is there's no Go module file that defines the module. I'm going to skip that for now, but I will come back to it at some point in the future, because you will need to either you'll need to use modules. I just don't want to deal with it right now. So we've got hello world, and so we know everything fundamentally works. Now, let's start looking at a couple of basic things. So I'm going to start with a lot of output and some basic variables. And I'm going to start with the four basic types that kind of everyone uses in every program, and that is an integer. So I'm going to declare a variable, and I'm going to call it sum int for some integer, and I'm going to use colon equals 4. So I've created a variable called sumInt, which holds an integer whose value is 4. And the next thing that people normally deal with are strings, like our little hello world message. So I'm going to say sum string is equal to hello world. The other two types that I want to introduce are sum float, which is a floating point number or a decimal number. So I hope your math is at least up to the point where you've covered decimal and floating point numbers. But essentially it covers things like interest rates or percentages or partial, like you have 3.5 of something, that's 3.5, but it's essentially a number that has a fractional component. And the other thing that we normally have are booleans, so some bool, and a bool is just a true false value. So integers, some contain the integers like 4, can be -1, 2 billion, whatever. Some string is just a string, some float is a number with a fractional component, and bool is a true false value. Okay, so let's go ahead and print these. So first, let's take our hello world message, and instead of printing that, we're just going to print some string. Okay. Now, there are times where we want to print integers, floats, and bools in kind of a readable fashion. So we're going to use a variation of the print functions called printf. Printf takes a format string, which describes how we want to print the value, and then a variable to substitute in the format string. So in this case, I want to print sum int. And in the format string, we're going to say %d for an integer. So it's going to put that sum integer into where %d is as substitution. So we can include other stuff in there like my value is, and we will do the same thing with floats. So let's say my int, my float value is. Now for floats, there's a %f, and with these I'll show you later. Now I don't remember what the format symbol for bools are, but Go has kind of a shortcut for whatever type, as long as it knows at some level how to represent itself as a string, and that is %v. So this is saying convert this integer to a decimal, a number. Convert this float to floating point. That's floating point string as a representation. Convert this bool to however it naturally wants to represent itself as a string. So if we save this, and to save I'm just hitting Command S on the Mac, it is Control S on the PC, and I assume on Linux as well. If I were doing this on Linux, I'd have it in front of me, but I don't. So I'm going by memory. So if I do run, if I go run get going now, I'll see that my output is all kind of smashed together. And the reason it's all smashed together is we haven't thrown any new lines in there. So we want to separate the output by telling go to put the output on a new line. There we go. So here we see hello world. That's our message. We see our integer value. We see our float value. And we see our bool value. Great, fantastic. I'm not going to lie to you and tell you you can go far with this printing stuff, but you need a little bit more Go knowledge to be able to really, quote unquote, go far. And so we're going to start with, I'm going to start with the if statement. So I'm going to say if some bool, and I am going to fumt print ln. And we don't need to add a new line thing to the end of println because println automatically knows to print it on to print one of those new lines at the end of the string. So I'm going to say some bool was true. Okay. So if I go ahead and run this now, I see that some bool was true. I see this message printed out because some bool was true. So if some bool is true, then print this message. Now, what happens if some bool is false? So here we go. We have the sum string, the hello world, right? We've got the value from some int, great. We got the value from some float, great. We got the value from this, great. But we didn't see this printed out. And that's because this was false. So the if statement, we don't enter the if statement. This never gets run. Okay, let me make this bigger just to make sure everyone can see okay. All right, there we go. So here it was true, so we saw some bool was true. But when we changed it to false and reran the program, we see that we don't see that output. Okay, so what have we covered here? We've covered the basics of bringing in a simple module like fumt, and we're going to go ahead and let the editor do that for us. We saw how to use println and printf, and how to format integer output using %d, floating point output %f, and if we're not sure the kind of output we want, %v. And we covered basic if statements. So if something is true, then go ahead and print the value, or execute some code, I should say. All right, got 10 minutes here. What else should I cover? Let's cover the fact that we can reassign values and variables. So I can say some int equals -7. And if I copy and paste this line in here, and I run the program, I save it and I run it, I see that my value, that output, my value is -7. Notice I used a different kind of equality here. So here I used a colon equals, and here I used a simple equals. So up here, what colon equals says is basically create me a new variable. And so as we hover over Summit, we see that it's a var variable named Summit, whose type is int. And we don't have to write that out. Go will do it for us because we're using the colon equal operator to allocate and assign a variable without having, it's called implicit typing, where we don't have to actually give Go the type. Go will figure out the type based on the value that we provide. So here we have implicit typing again, and it made SumString into a string. So if we hover over SumString, we see it's a variable named SumString of type string. Likewise, float is a variable SumFloat of type float64, which is the large floating point value. And here we have SumBool is a type of bool. Now, if I use colon equals again, I'd get the red squigglies. Why do I get the red squigglies? Because I've already created a SumInt. So if I try to create a SumInt down here, it's saying no new variables on the left side of the compiler, because the colon equals only creates and assigns new variables. If the variable is already existing and you want to put a new value in it, you just use equals. Now, could I have created a variable by giving it an explicit type? Yes, I could have said var, and I could have said other int, and this creates a variable, and I don't have to give it a value at this point. It's implicitly given the value of the zero, what Go calls a zero value of integer, which happens to be 0. But I can optionally also assign it a value like that. Now I have a red squiggle here because I've declared it but not used it. So one of the nice things about Go, in my opinion, is that Go won't let you leave unused variables and unused functions around in a program without giving you some kind of warning. And that's nice because that forces you to keep your code nice and clean. That is really good coffee. So other int is 200, and I can go ahead and print that. And if I run this, if I save it and run it, I see the output for other int is 200, right? Okay. I don't see it here, but sometimes you will see what's called, it will give you a kind of linting error. A linter is a, let's see if it gives me anything. No, it's not giving me anything. But a linter is a program that checks your code for style, and Go has a very good default style guide, but linters also check against, like common good practices. So if I were using a program, I might get like a yellow squiggly here, and that is telling me that, or a yellow light bulb or something, telling me that I don't need to do this declaration. I could have just gone with other int. And for all intents and purposes, that this style of declaration is the same as this when we intend our value to be an integer. And a lot of times the linter will tell you that you're being verbose if you're doing this. Now, there are times to do this style of declaration, and that's if we want this to be some other kind of integer. And we do have other kind of integers. We have a small int, which we'll see here. It's an int 16. So that is a 16-bit integer or 2-byte integer. Then we have the int 32, which is the same as the default integer. So when we have our int, just a regular int without specifying a 16, 32, 64, 8, that means we have a 32-bit integer. The default is a 32-bit integer. So then we've got a big integer, which is a 64-bit integer, which is not the default, and is useful for files. So a lot of times when you want to know how many bytes your file is, you'll get back an int64, because the maximum value that an int32 can represent is 2 billion and change, which is 2 gigabytes. But if you've downloaded movies, you know that movies can be 4, 5, 6, 8 gigabytes in size, and a number that can represent that would be an int64. And then finally, we have an int8, and an int8 is an 8-bit number, and that's more useful for more like systems programming, where we want to have binary data and we want to treat that binary data like an array of integers. Or we have some text interfaces kind of think of their data as integers. We also have unsigned integers. So we have integers. So the integers can represent both positive and negative numbers. Unsigned integers, or uints, only represent positive numbers, so 0 on up. And just like we had a uint, a default uint, which is 32 bits, we've got a default int, which is 32 bits. We've got a default uint. We've got a uint 16, uint 32, uint 64, and uint 8. This uint pointer down here is not an integer, it's a pointer to an integer. But the rest of these are integers. All right, so that covers that. Of course, we can use the same kind of declaration syntax with other things. For example, we could say var sum var other string equals howdy. And until we use it, so let's go here, change this to my other string is, and we'll put other string here. Until we use it, we get the red squiggles letting us know that we've got a variable that we're not using. And that is considered kind of an error and go. Oh, and we have two different kinds of strings. So we've got the double quoted string, and if we include, we can include escape characters like T. So T is a horizontal tab. So if I run this, I save it and I run it, I'll see that these are spaced out on their horizontal tabs. Now, I have another kind of string, which is to use the backtick key, which is usually in the upper left hand of the keyboard, if you're a US keyboard user. That'll do something interesting. That is a string literal, and those backslash things, like \n down here, don't get changed to a control code. They stay as a backslash. So if I run it again, I see the \t instead of having it spaced out like I did here. So here I had it spaced out. Here I use the backtick string, and the backtick string is nice to know about because it can span multiple lines. So if I run this now, if I save it and I run it, I see that my output now spans multiple lines. All right, and that's kind of it I wanted to keep everything down to about 30 minutes, and I think I'm going to do this every Tuesday and Thursday from about 7:30 to 8, and then take the videos and post them up on my YouTube channel. All right, well, have a good day, and I hope to see you again.